You know that feeling when someone's showing you how to do something that's really visual, maybe like a tricky guitar chord or figuring out a complex graph, and you're just sort of staring, thinking, I'm just not seeing what you're seeing.
Mm.
It can be so frustrating, can it?
Oh, absolutely. It's a really common experience, and it really highlights how much skill and knowledge in so many fields gets passed down visually.
Mm.
You know, medicine, trades.
Right.
Think about like an apprentice chef learning knife skills, or maybe a junior architect working with a senior designer. That hands-on guidance is just, it's often the key.
And that's exactly what we're diving deep into today. We've got this really fascinating collection of research. It's a review paper that pulls together lots of studies on how experts actually guide novices through these visually tricky tasks.
Oh.
So our mission, really, is to unpack this whole expert-novice thing to get at this idea of scaffolding. You know, that sort of temporary support experts give to help you, the learner, grasp complex visual stuff without just being totally overwhelmed.
Right.
We're going to explore the different ways this scaffolding happens, all based on this really solid research.
Because the way an expert sees something visually, it's often just fundamentally different from how a beginner sees it.
Okay, so let's jump right in. Why is it actually so hard sometimes for experts to teach visual skills? Right, these are the masters, right? Shouldn't it just flow naturally?
That's a really good question. And the research points to, well, a few key things. One is this idea called encapsulation. Basically, after years and years of practice, an expert's knowledge becomes super compressed, automatic even.
Automatic.
Yeah. Those little steps they learned way back when, they become so ingrained they're almost like invisible to their own conscious thought. It's like
Mm.
trying to explain how you ride a bike. You just do it.
Ah, right. Breaking down every tiny muscle movement is basically impossible.
Exactly. They're so deeply wired, they're hard to pull apart and explain step by step.
Okay.
And then you add in the jargon, right?
Yeah.
The specialized language. It's second nature for the expert, but it's like learning a foreign language for the novice.
Mm.
Plus, so much visual expertise is tacit. It's that unspoken, intuitive stuff, that feel for the right pressure or the tiny visual cue that just makes them react. That's incredibly hard to put into words.
So it's not just showing, there's this whole hidden layer of automatic, often unspoken knowledge.
Spot on. And here's something really interesting. The research touches on the expertise reversal effect.
Expertise reversal, what's that?
It suggests that sometimes when experts try to simplify things too much for beginners, it can actually get in the way of their teaching.
Get in the way. How?
Well, it might strip away context that the expert themselves relies on subconsciously, in their own mental framework,
Right.
which paradoxically makes it harder for them to explain it well.
Wow. Okay. That's completely counterintuitive. You'd think simpler is always better.
Apparently not always, especially if it kind of messes with the expert's own complex way of thinking. So the real question is, how do experts get around these challenges to actually guide learning effectively for visual skills?
And that brings us right back to this key idea, scaffolding. Now, the research we're looking at uses cognitive load theory to kind of frame how this scaffolding works in our brains. Can you give us the quick version of that theory?
Sure. So the basic idea is that your working memory, the mental space where you actively juggle new information, it's limited. It's like a small workbench.
Okay, a mental workbench. I like that.
Right. And you can only handle so many things on it at once. If you try to cram too much new stuff on there, you get cognitive overload.
Everything falls off.
Pretty much. Your brain just can't process it all effectively. The learning grinds to a halt, and you feel, well, swamped.
Makes sense. So the workbench gets too crowded.
Exactly. And this research review suggests that the main job of expert scaffolding is to help manage the load on that working memory. The experts in these studies used various teaching techniques, which the researchers basically grouped into two main types: cueing and chunking.
Cueing and chunking. Okay, let's unpack cueing first. What's involved there?
So cueing refers to things the expert does to specifically direct your attention, as the novice, to the really important information before it even fully hits that limited working memory.
Ah, like a pre-filter.
Sort of, yeah. Experts, because they've seen it all before, they can instantly zero in on what's relevant visually. Novices, well, they usually haven't developed that skill yet. Cueing helps bridge that attention gap.
So it helps you cut through the visual clutter and see what actually matters for the task.
Precisely. And the most common type of cueing they found in the research, it was almost 60% of the interactions they looked at, was active verbal cueing. That's the expert using spoken words to guide your focus.
Okay, using words. So how does that actually play out? What are some specific examples?
Well, one big finding was that experts give concrete bits of information to reduce your uncertainty. Instead of just blurting out the answer, they might give a targeted hint, or tell you exactly where to look, or ask a kind of fill in the blank question.
Hmm.
They might explicitly highlight a critical feature, or even do something the researchers called splicing in, where they sort of finish your sentence or line of thought for you.
Can you give a specific example from the studies?
Yeah, absolutely. There was one with a physics tutor who asked a student, will the green change to something new or not? See, by making it a yes-no question, the tutor massively narrows down the possibilities for the student.
Right. Makes it much less daunting.
Exactly. It makes it easier to focus on the key concept. The big takeaway here, whether you're learning or teaching, is how powerful just reducing that uncertainty can be. Give just enough info to narrow things down, keep that cognitive load manageable.
Yeah. That makes total sense, like putting the bumpers up in bowling.
Good analogy. Another interesting finding, these active verbal cues often trigger a nonverbal action from the novice. It's the look here or do this specific thing now kind of instruction, but said out loud. Think of a surgeon pointing out visual landmarks in the body and telling a resident exactly where to find them. Or, totally different field, a master woodworker telling an apprentice to strike the high parts first when using a specific tool.
So the words guide the physical action, where to look, where to put effort.
Precisely. And the research really stressed how important the sensory feedback is that comes with that action. The feel of resistance, how the material reacts.
Oh,
They
okay.
even noticed that when novices had more control, like they were driving the microscope in a pathology study, the experts gave more instructions about navigation and how things should feel, that tactile movement.
So it's not just seeing, it's seeing connected with doing and feeling.
Yeah.
That reinforces it.
Exactly. And a third thing they saw with active verbal cueing was reassurance. Experts often give verbal encouragement to help you, the novice, keep going, especially if you're feeling unsure.
That must be huge. Learning visually can feel really vulnerable.
Totally. It could be pumping questions like, okay, what else do you see? Or just echoing your words back to show you're on the right lines. Or simple phrases like, yep, you're on a good track there.
That little confidence boost makes a difference.
Absolutely. And sometimes it can even guide self-correction subtly. Like the expert might say, oh, you think so, with a questioning tone, making you pause and rethink without them directly saying, that's wrong.
Wow, clever.
Yeah. And the research even hinted that maybe experts find it easier to offer reassurance initially rather than jumping straight to critical feedback, which can sometimes feel awkward.
That's a really sharp observation. A gentler nudge.
Right. And one last point on active verbal cueing. The research showed it's mostly one-way traffic. Expert to novice.
Oh, the novices weren't asking many questions.
Not really, especially at the start. The researchers figured it might be because, well, you don't have the basic knowledge yet to even know what questions you should be asking.
The classic you don't know what you don't know.
Exactly that. And interestingly, this information seeking by novices actually seemed to decrease as projects went on. Maybe as they got a bit more comfortable, they relied more on the experts' prompts.
Okay.
So yeah, to sum up active verbal cueing, it's mainly about using spoken words to directly steer your attention to the important visual stuff right now.
Got it. Okay, so that covers active verbal cueing. What about active nonverbal cueing?
Right, this was a smaller slice, maybe around 12% of the interactions they looked at. What stood out here was that isolated nonverbal cues, like just a gesture or a demonstration with no words, seemed to require the novice to already have some level of understanding to really work well.
So just pointing or showing isn't always enough if you're a total beginner.
Seems that way. They expected to see a lot of modeling, the expert just demonstrating. But it wasn't as common in isolation as you might think, except maybe in fields like medicine, where the trainees come in with a ton of theory already.
Yeah.
There, they did see things like a senior surgeon starting a move and the resident immediately mirroring it because they already had the background to interpret that nonverbal cue.
Because the resident has the mental framework already.
Exactly. Nonverbal cues can be super efficient too, like using gaze tracking overlays in surgical training to show exactly where the expert is looking.
Cool.
But, and this is important, the novice has to be tuned in, have to be receptive. If you're hyper-focused on one tiny thing, you could easily miss a subtle gesture or a shift in posture from the expert.
Like that example of the surgical assistant missing the expert's body language cue.
Precisely. Okay, then there's the third type. Active combined verbal, nonverbal cueing. This showed up in about 17% of the interactions.
This sounds like the powerhouse combo, words and actions together.
Yeah, in many ways, it really is. The research found it's super effective for highlighting key visual landmarks. The expert says the crucial vessel is right there while pointing right at it. Or using one of those pointers on a screen during keyhole surgery to circle something while explaining what it is.
The visual and the verbal reinforcing each other.
Yeah.
Harder to miss.
Exactly. And it's also really good for clarifying how to use tools correctly. Imagine a dental instructor actually guiding a student's hand while explaining the movement. Shorter strokes, more controlled, like this.
Okay, yeah, the physical guidance plus the words.
Or a senior tech handing a tool to a junior and saying, use this one to apply pressure right here. You get the physical feel and the verbal instruction. Makes the learning much more concrete, more sticky.
Right.
So, yeah, to recap. Active nonverbal cueing often needs some prior knowledge, while the combined verbal-nonverbal approach uses both words and actions together to really nail down that attentional guidance.
Okay, brilliant. So cueing is all about guiding attention in the moment. Now let's switch over to chunking. What's the core idea there?
Chunking is more about helping you, the novice, organize the information after it's sort of entered your working memory. It's about structuring it into meaningful chunks or schemas, connecting the new stuff to knowledge you already have stored away in long-term memory.
So it's less about the immediate look here and more about building the bigger picture.
Exactly. Making it more manageable, easier to understand, and importantly, easier to remember and use later. Instead of just a confusing list of steps, you start seeing the patterns, the relationships.
Okay.
And the research found that experts tend to use more abstract, big picture statements, the kind that encourage chunking compared to beginners who might be teaching. The most common type they saw was active verbal chunking, making up nearly a quarter of the interaction.
Active verbal chunking. What does that look like in practice? How do experts do that with words?
Well, one key thing is they introduce the overall plan or procedure gradually. They might start by just reassuring you about the very next step, keeping it simple. But then, over time, they start explaining the broader order of operations and, crucially, the reasoning behind that sequence. Like the example of the stone tool makers explaining why you shake the bit first, then the butt, then the middle, because if you thin the middle too early, snap, it breaks.
Ah, okay. So building up that strategic understanding layer by layer.
Exactly. And eventually they might even start throwing in what-if scenarios to really deepen that understanding of the whole process.
Got it. Moving beyond just the how to the why.
Precisely. Another really powerful tool for active verbal chunking is using analogies. Experts are often great at linking new, maybe abstract information to something familiar from your everyday experience.
Oh yeah, analogies can be lifesavers.
Totally. Think of a dentist explaining how an instrument works by comparing it to a simple lever. Or a surgeon describing the pelvis as being shaped like a bowl to help you visualize the 3D space during an operation.
Right.
Or that physics example using a punctured car tire to explain air pressure. These make complex ideas much more concrete and easier to latch onto.
Yeah, those are often the real aha moments, aren't they? Suddenly it just clicks.
Absolutely. Now, the research also mentioned active nonverbal and verbal chunking, using actions and words together for chunking, but they didn't see many examples of this.
Okay.
The main way this seemed to happen was when experts demonstrated an entire procedure, explaining as they went, and then gradually handed over responsibility to the novice. That technique is often called fading.
Fading.
Yeah, think about learning to take blood pressure.
Mm.
The expert might do it all first, talking you through every step. Then maybe you do the cuff part, then you listen, and gradually you take over the whole thing with them just watching.
Makes perfect sense. Show the whole chunk, then let the learner build up to doing it themselves.
Exactly. So chunking, in essence, is about building those mental connections, providing that bigger framework for understanding, not just focusing on the isolated visual details or steps.
Okay. Cueing for attention, chunking for understanding. Got it. Now, you mentioned another category the researchers found, passive behaviors, or indirect scaffolding. That sounds interesting.
It is interesting. This is when experts deliberately don't step in immediately with instructions or corrections, even if you, the novice, are struggling a bit or make a mistake.
Why would they hold back?
Yeah.
Seems counterintuitive for teaching.
Well, the idea behind it is to encourage you to take more ownership of the learning process, to increase what cognitive scientists call germane load.
Germane load.
Yeah, that's the mental effort you put into actually understanding and integrating the new stuff rather than just passively receiving instructions. By stepping back sometimes, the expert gives you the mental space to wrestle with the problem yourself, try things out, connect the dots.
So it's about letting the learner struggle constructively to build deeper understanding.
That's a good way to put it. Constructive struggle. The research found experts often do this when they feel the novice has got a decent initial grasp of things. You might hear them say, okay, stand back and see what you do now, or, right, your turn. But the research also really stressed that this needs time and trust to work well. It's often more common and maybe more effective in longer-term mentoring relationships where the expert really knows the learner's level.
Right. You need that established relationship.
Definitely. And sometimes just letting the novice see the natural consequences of their actions can be a powerful lesson. Like that bakery apprentice whose dough wasn't quite right, leading to a visibly different loaf. No yelling needed. The result spoke for itself.
Learning by seeing the outcome, even the errors.
Exactly. They also noticed experts might become passive if a novice seemed really stuck, maybe to give them space to think, or perhaps later in an interaction turn. And interestingly, older, more experienced tutors seem to use this passive approach more often.
Maybe more confidence in the process.
Could be. But, and this is really important, the research warned that being too passive, especially too early, or if the novice just doesn't have the basic concepts down, can backfire. It can leave the learner feeling completely lost and frustrated.
Yeah, I can see that.
If the feedback is just, that's wrong, but with no explanation of why or what to focus on, it doesn't actually help build understanding. It can just shut down the learning.
So it's a really fine line for the expert to walk, isn't it? Knowing when to step in and when to hold back.
Absolutely. Which loops us back to how crucial it is to balance both cueing and chunking effectively. The research makes it clear they aren't separate things, they're often used together. Like when an expert narrates what they're doing while demonstrating.
Right. Talking through the actions.
Yeah, that gives you immediate cues about what's important, cueing, while also building up your understanding of the whole procedure, chunking.
That narration seems super powerful. You get the what's the why simultaneously.
Exactly. And the research suggests that novices, especially early on, really need those direct cues. Because, like we said, you often don't know what you don't know. Cues get you started, focus your attention, stop you feeling overwhelmed right away.
Makes sense. First steps first.
Right. But then as you get more familiar, as you start building that basic knowledge, the chunking strategies become more and more important. They help you build that deeper, more independent grasp of the visual skill.
So the balance shifts over time.
It seems so. The research even compared different mentoring styles. Some focused heavily on instructions and explanations, lots of cueing. Others pushed more for reflection and problem solving from the novice, more chunking, and that indirect scaffolding. And that second style seemed to lead to more independence in the long run.
Fascinating. So it's this dynamic process. The guidance needs to evolve as the learner evolves.
Precisely. Cueing might be more dominant early on, but chunking and maybe more passive approaches become increasingly valuable as you gain experience and start building your own solid mental models.
This has been incredibly illuminating. So if we boil it down, the big takeaway for listeners is really about this dynamic dance between cueing, guiding that immediate attention, managing the initial mental load, and chunking, helping build the deeper connections, the lasting understanding.
That's a great summary. And really getting a handle on these cognitive mechanisms, it can be super helpful, right? Not just for experts wanting to teach or mentor better in visual fields, but also for anyone learning these skills. You become more aware of how you learn best.
Yeah.
What kind of support actually works for you at different stages.
It really makes you think back, doesn't it? To times you were learning something visual. What kind of scaffolding helped you most? Was it those direct pointers right at the start? Or was it the analogies, the bigger picture explanations that really made things click later on? Maybe just reflecting on our own learning through this lens of cueing and chunking, that could give us some really useful self-awareness.
That's a brilliant thought to leave people with. And, while we've mostly talked about face-to-face, real-time stuff today, based on this research, it feels like these core ideas about managing cognitive load, guiding attention, building understanding, they almost certainly apply to learning online or in blended settings too, right?
Oh, absolutely. How
Yeah.
scaffolding works remotely.
Yeah. That's maybe a whole other deep dive waiting to happen.